Hey everyone, welcome to Howdy Partner. We are a Twitch show that showcases our friends from the Partner Network, the AWS Partner Network. With us today, we have some of our partners from OnDat. I would say good afternoon to everyone, but they're from the UK, so they're staying up late to come and hang out with us today. We're going to be showcasing one of their solutions. It's called Disco Blocks. That's one of the things they're going to show off, and it helps leverage EBS and EKS and blueprints for EKS, and I'm sure a couple other things they can mention. With me, my co-host Shardul, he's going to give a little. He's going to talk about some of the services we're going to be doing and going over, just to give everyone kind of a level playing field. Any new people that might be joining us want to just learn about AWS in general, and then we can see what they've actually done and built with those services. So, Shardul, if you want to take over and give us a little intro of yourself.
Yeah, hi everyone. I'm a partner solutions architect here at AWS. I've been here for 8 months, and I'm going to give you all an introduction on EKS, which is Elastic Kubernetes Services, EKS Blueprints, which is something that OnDat uses, and EBS, which is the backbone of Disco Blocks. So EKS is AWS's fully managed Kubernetes service. It is Kubernetes, if you don't know, is a container orchestration service. It essentially manages how your various services turn on, turn off, even how data is flow or data flows through various services, and how well, yeah, it's something that controls how all of your containers run. In the case of EKS, it is also fully compatible with AWS Fargate, so you don't even have to worry about spinning up clusters. You can just say, "Hey, run this task for me." Um,
Nice.
yeah,
So, like, so what are containers exactly? I don't know. Maybe people don't know.
yeah. So containers. It's a very good question, James. Containers are they're lightweight, fully packaged little essentially files that you can run on any service that lets you run containers. They're fully packaged, self-contained applications. So you will have, the service that you're running along with all of its dependencies all packed up, and then just send it off to a container engine to run.
And we have a question in the chat. How does EKS compare with ECS? Do you have a good answer for that?
So yeah, I do. So ECS is just our container service. This lets you spin up and spin down individual containers manually. But EKS is our orchestration service, so it lets you run more complicated tasks that may be driven by something like step functions um, or other management services.
And I think ECS is serverless. You can run ECS serverless, so you don't have to worry about managing like underlying instances and such. How does ECS check health of the container? You can set up different parameters, um, and you can set up different. It does well. That's a good question. I'll come back to it. Or maybe our partners here can better answer uh, that question. Let me go ahead and introduce our partners here real quick. We have Farhan and Angelos. They're from OnDat, and so Farhan he's an engineer. He's been building for over 12 years. He loves martial arts and he likes doing extreme activities like climbing, snowboarding, surfing, skating. And Angelos is one of the product reliability engineers, and he's been working at DevOps for the past 4.5 years. Um, he likes playing chess. I know a lot of our team likes playing chess, and he plays the bass. I don't know if anyone else plays bass. You guys can make some bass chat. Um, I don't want to talk over them too much.
No,
Fran,
thank
I
you.
guess I'll kick it over to you for now.
Yeah, thank you for the introduction. You were talking about the ECS, and I'm sure ECS, the way as EKS has the health checks that usually you can query certain parts of the container. Some containers have return codes on what they run inside, but also some containers usually have health check URLs, kind of thing. And on that, usually you can actually verify that if something is running. So there is a component of returning codes on Linux, and there is a component of your application being able to respond to certain success codes. Let's put it this way. Um, Today we're going to focus a bit more on EKS on the Kubernetes side, mainly because at OnDat provide we built a solution over the last 5 years that is to provide persistent storage, production grade persistent storage for containers. So if that's okay for everyone, I'm gonna start sharing my screen, and we can kick off on that area, unless Shardul had something else to cover beforehand.
Um, I was just going to discuss what EKS blueprints are, but if you want to cover that, we
Go
can
for
do
it.
that too.
Go for it, because then I'll give also a bit of my perspective, or a bit of color on that. So it's better to hear from you guys first.
Yeah, absolutely. So EKS blueprints are um, essentially a method to templatize Kubernetes clusters. You're going to, if you're familiar with it, you have stuff like Terraform and CDK, which lets you write infrastructure and services that you're using as code, and EKS Blueprints is just an extension of that. So they let you leverage CD services to consistently deploy templated clusters over any region and any availability zone. That's all they really are. It's templatizing EKS clusters.
Cool. So is that like could you kind of think of that as a similar thing to like CloudFormation or IAC, but in like kind of the EKS kind of space? You could kind of see a similarity, I guess.
Yeah, exactly. That's exactly what it is. It lets
Okay, cool.
you it lets you templatize and codify your Kubernetes configurations.
Nice.
Yeah, and Fern, right back. I'm gonna pass it back to you.
Sure.
Let's get this going.
Yeah, let's get this going. I want to cover a bit of the blueprint, because the other day we were with a customer, and we had this thing that they didn't build a reproducible way to templatize exactly the cluster, exactly what you're saying, and it was painful. Let's put it this way. So we're gonna cover a bit of that. um, yeah. So let's do a small verification on the screen share. So I'm on my slides now. Can you see my slides? I'm not sure if that's a
Not
yes or a no.
not yet.
Not yet. Let's load them. So,
There we go.
to
That should be coming up right now.
yeah,
There we go.
cool. Let's do a double check on the fact that you can see my shell.
Yep, looks good.
Fantastic. So we can work on that. So today I wanted to cover. By the way, before I start, please throw as much questions as you want. We have a few questions prepared in some polls that we prepared. Please, you will see a link, and go answer them as soon as you can, because that will give us a bit more interactive, an interactive platform, because we want to give you something, but also get something for the audience that is not only about throwing slides to you. So we're going to do a live demo. We're going to shoot machines. We're going to shoot the things. We're going to talk a bit about principles and concepts that we're seeing, but also we want to see a bit of the temperature of the audience today, see what you guys are doing, and see how you're doing. So please, at any point, ask any questions, fill the form that we have, and you can ask anything about anything. You can ask about my background if you want, which has a story on itself. About anything you want, just please go ahead. This is for you guys. So
Yeah. Hey, friend, let
you're
me cut
saying,
you off for a second. Sorry.
yeah, go on.
We have a question. I know what EC2 is. I know Lambda. Not too sure what EKS is all about. Are you able to
Mhm.
clear the doubt?
Sure.
So,
So yeah.
yeah, you go ahead if you want to field it.
I would just say that is the Kubernetes distribution that Amazon Web Services provide for us. So instead of having to run a Kubernetes cluster on my own, Amazon give me the capacity to click a button and say, okay, now you have a full Kubernetes cluster with 3 masters, which is a Kubernetes. Kubernetes is a container orchestrator that orchestrates containers, associates containers to CPU and memory. So in the end, we have a bunch of definitions of applications that need to run in containers. Those applications need CPU and need memory, usually network and disk, but mainly CPU and memory. And Kubernetes is capable to aggregate a bunch of nodes, convert them into a cluster, and start throwing applications into various places to be able to run. On top of this, it gives you networking, it gives you capability for scaling containers, so running multiple instances of the same application in a declarative way, etc. So in the end, EKS is the Kubernetes distribution that Amazon Web Services provide for us without having to maintain it ourselves, without having to maintain our own control plane of Kubernetes and workers. It gives us the control plane, and we just need to deploy applications.
That sounds like a pretty good answer. A little more, even more in depth than I thought it was. I just gave the TLDR real quick in the chat there. Just, yeah, just if you know what containers are, Shardul kind of mentioned what containers are. Just think of them as little miniature applications you can run anywhere. Kubernetes is a way of just managing a whole bunch of those, like how many of those you need, or if one of them fails, it'll spin it back up, kind of thing. EKS is just the AWS managed version of that, and OnDat has been able to leverage that to build even further and make things even more more scalable and more usable.
Cool. So do you have any more questions before we start?
No, that looks it for now, except for
cool.
I was going to ask, where are you right now? Like,
so I have lived in a van, so I'm doing a bit of a nomadic lifestyle of late, for like almost a year now. So I used to live in London, and now I live in a van, more or less. So now I'm in the Atlantic coast of France, following waves and swells, pretty much. So yeah, what you can see is pretty much my van, and the internet hopefully is working fine with my 4G connection. It's redundant. It's we're engineers still, but it works pretty well still.
No, you're good so far. Everything looks good. It's just wild that you're able to do your whole profession from a van the last year. That's crazy. Anyway.
Yeah, it's I really love it, to be honest. It's actually great. But yeah, I'll keep going because I could go for hours on this. So
yeah, go ahead.
Cool. So questions on the forum first. Who is using EKS in production and for how long? So I want to know from all you guys, are you using Kubernetes in AWS? Have you been using it for long? You're using it for production, you're using it for development. So we have this poll already sent on the links. Please, if you fill them, Angelos can give us a bit of the information on what's going on there, so we can have a bit of a comment and see what's going on. So Angelos, if you want to come in, please feel free. Otherwise, I'll just press ahead. Cool. So we were talking about EKS blueprints before, right? And what I've seen using the blueprints is that what gives us is the capacity to describe many things, or describe a cluster in its entirety. And what is a cluster? A cluster can be defined in many ways, but one way to say or to define is, hey, it's hardware, it's the Kubernetes control plane, it's the Kubernetes workers, it's infrastructure components that run on top of Kubernetes or on top of the machines that run Kubernetes, add-ons, and that's the cluster. And then we add the applications. The applications in the end are business applications that are running our business model. So all this is bundled and templatized using a Terraform-like model. So with this, what we can do is build templates that are actually quite easy to read and quite easy to maintain, that are tailored EKS clusters. So for instance, OnDat here could come into the infra component as something that runs on top of Kubernetes. It's a storage layer, but we deploy as a Kubernetes application. There are add-ons. You can install, for instance, registries. You can install things that scan images for security. There are many, many things that you can add, or even other CSI drivers that you can add into a cluster that when you deploy an EKS, you just get the control plane of Kubernetes and you get workers. Yes, you get the hardware. You need to define it a bit because you need to define what, for instance, in this case, what virtual machines, what EC2 instances you have there. But that's about it. With this, it gives us a lot of capacity to be able to define a production-grade cluster and to be able to reproduce how the cluster looks like. This is very interesting because, for instance, if you've used EKS CTL, which is a tool that's is widely used to provision EKS clusters, it's a Go program that allows you to pass some YAMLs and define a cluster. This is way more flexible. I can have a cluster that is production-like with all its topology, all its settings, and in 2 clicks, I can have another cluster that looks exactly the same. And as I was saying before, we had this customer the other day that they had some deadlines, so they cut some corners. To be honest, we all have done that. So there is no perfection here, but they got to the point where they added a lot of complexity because they required high levels of security, and they had some requirements. And because they didn't follow this model, when they had everything set up and everything worked and they had to go to production and build another cluster, it take, instead of like 10 minutes or a click, it take them a couple of weeks to be able to go through all the changes and specific details that they made on their cluster to make it work again. So it's good to invest in time on templatizing these things beforehand. Cool. So who's using stateful applications in Kubernetes? In the end here, as OnDat, as a company, what we provide is data services for containers. So I want to know who is using stateful applications. And by stateful applications, I mean things that need to store state into disk. And when they restart, when they come back up, that state needs to be there. I'm thinking about Elasticsearch, Prometheus, Postgres, MySQL, Kafka, any application that requires that application that handles data. Cool.
Going back to what you were saying just really quickly, Farhan, about having to rebuild clusters over and over. My previous position before I joined AWS, we ran almost everything. We ran almost everything on EKS, just about. And yeah, I kind of got thrown into the position where our DevOps guy left and I had to learn everything and do it all at once. And having to rebuild the cluster every single time for every project, yeah, I wished I would have been able to know how to templatize it, and because that just ate up so much time having to spin them all up, get Nginx going, get all our ingress, get everything all. It was I wish I would have had that and the knowledge of it, because would have saved not just time but stress, like saved my sanity.
Yeah, there are so many things that you just go there. It's like, oh, why is this happening? Why is this not working? Oh, I'm missing a registry. Oh, because that registry was installed by someone at some point. Like, no, just, I need to know where things are, and this needs to be reproducible. So, yeah, it's really about saving pain and time. It's we see that every day, and it's easy to start and start building things and not think too much about it, and those things start growing, and all of a sudden you have this thing in hand that you have to maintain that is painful and hard. So starting, if you have to start from scratch, guys, try to build things that are reproducible. Yeah. So
Sure.
Angelus, do we have any input from the polls, from questions that we want to discuss?
Yep. So for how long people have been using EKS in production, it looks to be pretty much a split between people using it for less than 6 months to up to 3+ years. Pretty much one vote for each section. So it looks like we have a variety of responses.
Nice.
And for the stateful applications, it looks like a lot of people are using Prometheus. Most people seem to be using Prometheus in the production environment. And then a mix of Elasticsearch, MySQL, Kafka, Cassandra, and also PostgreSQL.
Mm-hmm. Okay, so pretty much we're using EKS. Some people are new to it. Some people are wizards already, and we have people running stateful applications of all kinds, right? We have queues, we have messages, we have databases, pretty much, and indexes. And about GitOps, do we have much information about this?
We probably don't have that
Sorry,
much
let me-
yet for
Not
that
yet.
one.
Cool.
Yeah.
So
Okay, let's give it
to
some
give
time.
you an idea with, for instance, the information that we have, we go to talk to customers daily. Like one of my jobs is actually go and have like technical conversations with customers, architectural conversations. And I could say that people that use GitOps, I could say is 60-40% on the people that we see. 60% on people that use it, 40% people that don't. They didn't use GitOps, that doesn't mean that they don't have reproducible. It means that they don't have the full workflow implemented, let's put it this way. So it's not necessarily completely cowboy style. That could be like maybe like a less than a 5%, at least in my anecdotal experience. So besides the information that you guys can give, this is actually what we see in the industry. So we're going to talk a bit about these principles on code, state, compute, and data. So when we are talking about code, usually we have software that follows a life cycle. And that life cycle has been evolved for over the last 40 years. And nowadays, we have a model where we have pipelines, we have automated tests, we have a way to package that software and to release it. And we want to do something similar with infrastructure. And by doing that, what it means is we want to keep our infrastructure in a way that we can do things like code reviews, share the information, and keep track of changes. Not necessarily for blaming people, but to understand what happened. So keeping infrastructure in a way that can be templatized, that can be put in code, gives us all the principles that software already follows, which is actually pretty good, and it's proven to be the way to go. Then we go to state, and in this case we're using Terraform because blueprints mostly use Terraform. But there are other ways to keep state, which in the end is, hey, I want my infrastructure to look like this, pass from something that we define, for instance, in files and then in Git, to this is my infrastructure, it's provision, and when it changes, because the infrastructure changes all the time, I want something to keep state on the change on what's happening, but moreover on keeping the state of having things in the way I want them to be. From there, we pass to compute. In this case, we're talking about Kubernetes because we're going to be focusing on that today. It doesn't have to be Kubernetes, but it's what we're covering today, which is an orchestrator that gives us the capacity to allocate applications. So once we have the infrastructure, everything is provisioned. Now I need to run things. I need to run my applications. I need to deploy containers. So I have a bunch of servers, a bunch of instances, and I want this orchestrator to allocate applications where they can run properly and they can have access to the network and they can actually have access to data. So nowadays, the data area on these steps is probably less known. It's more traditional in the way that is not implemented, but what we see in the industry is that while software and infrastructure as code has been evolving, the state has been evolving for the last 10 to 12 years with Chef, with Ansible, with Puppets, with Terraform. Data and the way the data is managed didn't evolve that much. So we try to come here and we built a product for the last 5 years. We built software that at OnDat that tries to solve some challenges. What are those challenges? First of all, that containers are ephemeral. So yeah, you have this application, and if you think, for instance, of a web server, you can take a web server, you can package it, and you can tell Kubernetes, I want you to run 5 instances of my web server. My Kubernetes has, let's say, 20 nodes, 20 EC2 instances that therefore has quite a lot of capacity to run CPU and memory. And I'm going to say, look, for this application, for this web application, I need probably 1 CPU and 5 megabytes of memory. And I want you to run at all times 4 instances of this container. So Kubernetes will go there and run it. But what happens when I write to disk and I stop one of the containers? Containers either are created or deleted. They cannot be amended. And that means that the data that is stored in that specific container goes away upon restart. So what's going to happen is I can lose one of them. I have 3. Kubernetes will see that I'm supposed to have 4 instances of that web server. I have 3. It's going to spin up another one. But this is a new one. It doesn't keep the data. So containers, by definition, are ephemeral. Nodes are ephemeral as well, and mainly on cloud, because what we want is machines that can be recycled. So even though we can keep, for instance, EBS, and we can keep data in certain stores, nodes can be deleted at any point in time. And we can create new VMs, new EC2 instances at any point in time. So all that, if we combine these 2 situations with the fact that when you have data, data needs to be accessible at all times. If you have an Elasticsearch, if you have a MySQL, if you have a Postgres, you need access to the data all the time. It's not that you're going to use it 100% of the time. It's that when you need access, it needs to be there. So if we have containers that are ephemeral, but our data needs to be there, how do we do this? And that's what OnDat comes to solve. And needs to solve it with performance and needs to solve it with data protection. So in the end, we built a product, or we built a software following these 8 principles, or these 8 core principles. It needs to be declarative and self-storage and self-service storage. What does that mean is, and I think this is a paradigm change in my opinion, because we pass from a traditional model of handling storage where storage was given to computers, to operative systems, and operative systems could mount this storage one way or another, attach, mount, and applications that needed to start in certain spaces of the file system to use that storage. Now, this is a lot of moving parts, and this is not very flexible. So we built a system that is application-centric. That means that Postgres as an application can start on Kubernetes and say, I need 50 gigabytes of capacity. Give it to me. And that is what it means, self-service. It means application-centric. It means Postgres will ask me, I need this, give me this. And the system, in this case OnDat, will give that capacity. But obviously, we'll give that capacity in a way that it's to be really low latency, so it needs to be highly performant. It needs to be scalable, and above all, high available. So remember that we said that containers are ephemeral. So what we do is we keep that state. So in case of Postgres stops, when it starts again, data is available. But not only this, when there is a failure on a node, because nodes are also ephemeral, we keep data in sync in between different nodes. You can control that per volume. And in this way, we can say, okay, Postgres, now you can start anyone you want. And Kubernetes would say, okay, this machine doesn't work. I'm going to put it in this other instance because I have more CPU, or it works better. I'm just going to put it there. Upon a failure, the data is available. The data is accessible in that other node. We will handle all the network traffic if the data is not exactly on the same node where the Postgres is located. So there are a few components here that we focus to build this product. And finally, before I go to a bit of a demo and I start shooting things, I'm going to give you a bit of context of how do we install. So we say that we're shifting storage left. What that means is we're approaching storage to development instead of being storage just for storage engineers. Now, what we do is we install in Kubernetes, we have an operator and we install different components. But in essence, what we end up doing is we end up taking the workers of Kubernetes and we are transforming those workers onto disk arrays. So what we are doing is we're taking capacity of the nodes of the workers of Kubernetes, and we're virtualizing a layer there. We're creating a pool of capacity, and we can create hundreds of persistent volume claims in Kubernetes, and we will end up writing to the disks available on these machines. Any questions until here that you want to cover before I go to a bit into a demo, show the blueprints and on that?
Uh, yeah. Well, I was gonna ask real quick, like, so from a high level, what you're saying is, uh, OnDat makes it so, like, when I want to, instead of having to constantly like adjust my volume claims or my node size or whatever, it will scale it dynamically, but still be able to keep that like consistency. I forget what the word you used. Like if there's a
Mhm,
failure.
mhm. So one of the main situations with such a ephemeral architectures is that nodes can come and go at any point in time. So we take nodes as the unit of failure, right? So what we do is we create a system where you can provision a persistent volume claim, and that persistent volume claim, you can define how many instances of data, how many replicas do you want for that claim. So for instance, if we have one replica, we have two copies of the data, the primary and its replica, and that is synchronous. So that replication is synchronous. That means that every write goes to two places before it's acknowledged to the file system. So in case of an application goes down or a node goes down, we automatically fail over the replica. We promote that replica to a primary. That takes milliseconds. We have our own health checks and all that stuff. And the application will be able to access data. In fact, if what's failing is not the whole node, but a part of the node, we will handle all the network traffic in between the primary and the application. So there is no downtime for an application accessing to disk or to its data. And
Okay.
yeah, and all of that is done in a way that persistent volume claims might be like 5 gigabytes, 15 gigabytes, 50. And we aggregate all that. And in the end, when we end up writing to the 1 terabyte disk available in the worker, which is one or two disk or five. But it's not like there are no hundreds of disk on these workers, but we can have hundreds of PVCs on a cluster.
Okay. Um, and just for everyone, when you say PVC, persistent volume claim, could we think of that like we could think of that as like hard drive space, kind of, right?
Mhm.
Like a container gets assigned that amount of storage, right? Is that a good way to kind of
Mhm. Yeah.
lower it down?
So there are two objects in Kubernetes. There are persistent volumes and persistent volume claims. For the guys that are not that familiar with it, think about persistent volume claims. Persistent volumes, for the people that has a bit more experience with it, one usually maps to the other. But a persistent volume can be thought of a disk, and a persistent volume claim can be perceived as a chunk of that disk that is owned by an application. In practice, it's not exactly like that, but it's a way to say, I want some capacity. That capacity is owned by an application, by that Postgres. And that data there it belongs to that Postgres. So as soon as the application writes things there, we have an object that stores data, that has data, that even though the application stops, let's say we scale down the Postgres to 0, and we don't have any application running, the data is still there. And when the application scales back up, let's say to one instance or two instances, the data will still be there. So we defy the purpose of the fact that containers are ephemeral. This can be done in a very naive way. We can say, hey, I can write to the host that I have available, not the container, but the host underneath. What happens if the host goes down? What happens if I have many in the same place? So you start needing a bit more of advanced functionality for data services. You start needing replication. You start needing high availability. What happens when I want to move my application from one node to another? Because one node, for instance, is overloaded. If my data is in one node, I cannot access the data from a different place. When you add things like OnDat on top that has more logic to it, you can start doing all these operations into the cluster, and therefore have high availability and have a production grade stateful application running on Kubernetes. If that makes sense.
Yeah, it
So,
makes sense.
can I chime in for a second?
Please.
Let me get this straight. You're essentially decoupling storage from the Kubernetes cluster so you can manage it individually.
That's an interesting way to see it. So we are decoupling storage. Yes, we are taking away the storage that applications see to the storage that is available in the hosts. We have that layer in the middle. And what we're doing is virtualizing we are virtualizing volumes. We're virtualizing disks. So when a Postgres, for instance, says, I want 15 gigabytes of data, those 15 gigabytes of data are not mapped to map one-to-one to a disk in the worker. We virtualize those 15 gigabytes. We end up writing to disk, but we control every single input-output operation that happened to that disk. So we control those 15 gigabytes, how they are managed. So yes, we are disaggregating or we are removing the tightness of an application to its disk. We have an application to a volume, and the volume is an object that is an OnDat object that can move, that can be placed in different nodes, that can fail over, and has all sort of services thanks to this decoupling.
That's awesome.
It actually is pretty awesome, I have to say.
Exactly.
It sounds really bad to say there.
No, I
so,
mean, you've established a method to essentially go from applications that just exist in space and then given them a real grounding and all of that in a completely transparent way. So that's incredible.
Yeah, so I was about to show the Terraform, and so I provisioned my cluster with this EKS blueprint that I have from that installs a topology, stuff like that. And I'm going to show this a bit later because now we're talking about how volumes work, how applications work on Kubernetes, and I think it's more interesting to go there first. So all this that we were talking, let's materialize a bit. So what do I have? I'm going to use K instead of kubectl, but kubectl, kubectl, whatever you want to call it. So I have a cluster that I provision with an EKS blueprint. Again, it's reproducible, so I can provision as many as I want with the specific settings and setups. So in these machines, I'm using specific boxes that Amazon have that has NVMe drives. NVMe drives are really fast, solid state. I think they are really fast disks. Let's put it this way. So I can use EBS as the network attached for these two instances, but also I am using the NVMEs available on these machines to give that to OnDat, so OnDat can write onto a disk that is super cheap because it's local to the host that is running the VM, and it's super cheap. Obviously, because it lives in one node, if I lose this node, I could lose data. What we're doing here is we're giving OnDat's replication to give a factor of risk of losing nodes is that losing nodes give us the capacity to be fine. It's ephemeral, but we keep replication across nodes. You can choose how many nodes. So in the end, you can leverage really fast disk and have replication as well. So what I was talking about the applications here is, look, I have a Postgres running. And this Postgres is a container or is a pod. If you're not familiar with pods, is the smallest unit of an execution in Kubernetes. So imagine a container or multiple containers that run together with the same network space, same file system. Now, this Postgres has a persistent volume claim associated to it. So when I created the Postgres, this is a stateful set, which is a controller that will make sure that I always have one instance of my Postgres running, have a persistent volume claim. That persistent volume claim is of a storage class, StorageOS rep, which is StorageOS replicated. Now we have an application, Postgres, that is claiming a chunk of capacity. They're like, I need 25 gigabytes, give it to me. And by the way, I want it with these characteristics. And this characteristics is that is OnDat replicated. And by the way, it says StorageOS because OnDat is formerly known as StorageOS. Our products are still called StorageOS, even though the company is called OnDat. So everything you see StorageOS is an OnDat product. Cool. So what is this coming from? What is this data that Postgres is writing going to? Cool. So when we install our operator, and we install among other components as a daemon set. So what we have is a daemon set, which pretty much means I'm going to run one instance of this container on every node of the cluster. Remember that I said that OnDat aggregates the capacity on the workers. So this is the container that will take the capacity of every worker and be the OnDat node. So in this case, I have 5 Kubernetes workers, 5 OnDat nodes. So that data is stored in these containers and is stored in disk on the workers themselves, and a specific location on the file system. And here we can start seeing, okay, what happens here? So we have different components. So to give you context, I connected my cluster to the portal, the OnDat portal. This is a SaaS offering that we have that can connect multiple clusters into one place. So for instance, I have my ephemeral disk cluster here that I already connected before. So I can license the cluster, I can apply license and things like that. So what we can see is that I have multiple persistent volume claims. Here we can see the Postgres. It's a read-write volume, that means it's fast. And if I go check with the CLI, I can see, let me see here, volumes. So I'm just executing into a container. Don't worry too much if you don't see what's going on. Just get into the point that I'm running this command, storage.os get volumes. Let me put this a bit higher. So what we see is that I have a volume, which is the Postgres one, 25 gigabytes, and it's located in a place. So we are storing the data actually on this specific machine. However, and I did this on purpose, is attached to a different machine. So let me do a describe. It's going to be a bit easier to read. So what we're saying is the application, the Postgres, is running on node 103. The primary volume where we store the data is in node 249, and we're handling all the network traffic and everything. That's completely fine. Also, we have a replica on a different node, the 106. So every time we write to these two places, and that's it. So what's the interesting thing about this? So the interesting thing is what happens if the node that holds data is gone, right? Because we said the nodes are ephemeral, but not only ephemeral, they fail, they have problems. Someone can shoot a node. We can downscale a scaling group. What will happen when do this? And this is actually one of my most favorite parts of doing live demos, which is I'm going to shoot things, and I did some sacrifices to the demo gods, and it's going to work fine. But in the end, what we're going to do is we're going to remember this node. We're going to remember where the replica is located. So let's go and shoot this node, the 249. Let's find it. So I have my 5 instances that are running an EKS cluster. Let's find the node. Instance state. Let's double check. It's a 249. Instance state. Reboot. I'm going to do reboot because it's faster. Obviously, I can terminate it and it's going to be the same result, but this is going to be a bit faster to see. It's going to take a couple of minutes to do the whole reboot. So let's go back here. So let's describe the volume again. I'm sure I'm accessing the CLI in the wrong place. So in the meantime, I'm going to go inside the Postgres application. I'm going to get a shell into it. So I can do, let's actually this. Postgres writes data into /pg data. We have a volume, it's a device. What this in the kernel is no more than if you plug a USB, a disk, an SSD, it's a device. It's a special file that says I have blocks in here that you can write data. So if I go to /pg data, I can see that I have the Postgres data, right? Pretty simple, pretty obvious. Cool, but remember that I just rebooted the node that holds the master data. The primary of the data, I just reboot that node. So let's go and run the CLI again. Because I probably should the node that holds the CLI. Let's see. Remember, I shoot a node And now I'm listing the volume again. And the node that we had the replica now is being promoted. While we create a new replica, this is declarative. There is a new instance of data being synced somewhere else. So now we keep reading and writing to the primary volume. And in the meantime that this was happening, I just exec into the container and I show you the contents of the Postgres. That pretty much means that even though there was things breaking, I was able to keep writing data or actually looking at data, accessing the data in the container. There is no restart on the pod. There is no glitch on the application. The data has shifted from one place to the other, and we have shipped the network underneath, and this keeps running fine. And if I exec into it again, and I get a shell again, and I go into the place where there is data stored, I see that things keep working normally. I can touch a file. It's just writable. So I was not only shooting things, is we came inside the Postgres application while things were being shifted underneath, which I think is actually pretty cool. Now,
that is cool for sure.
Let me check my time. Let me make sure, because we can do this for I can do this for 1,000,000 hours. So it's really awesome, actually. Like you don't come to realize sometimes how like this is so cool. Like in a matter of milliseconds, I shoot something and things keep working and recover. One thing I want to show you as well is actually I might go to the to the Terraform on time 47. Yeah, that's fine. So one thing I wanted to show you today is the EKS blueprint as well. So I show you a bit shooting things. Shooting things is fun on a demo. Everything works fine, and we recover automatically. It's fantastic. But how do we get here? How do we get to this point? So this is the output of the Terraform that I run, and it's gigantic, so I'm not going to show you. But what do we have there? And I can show you this here. I can show you this in GitHub. I'll do it here. So this is the EKS blueprint that we built for a cluster to use the NVMEs, the ephemeral disks. We have multiple ones. We can use a getting started. We have the ephemeral disk. We have another one. So what this does is giving us the capacity to templatize the cluster from what VMs I'm going to provide, which version of Kubernetes, how the workers look like, what infrastructure components like OnDat. This is installed using OnDat through the Helm charts extension. And I can choose not only this on the Terraform template of the EKS blueprint, but how I'm going to set up the machines. And this is a big differentiation when it comes to the EKS CTL. So if you look at here, I have an EBS. And this EBS is for configuration, mounted in bar-lib storages of the host. And here is where the interesting things come from. I'm able to say, plug the NVMe, the super mega fast disk that is very cheap because it's local, into the location where that will write data. So by having this template, I can recreate this cluster with the same settings, with the same setup in a matter of seconds. On top of that, we can add the Kubernetes add-ons blueprint or the blueprints add-ons, which lets me use the Helm chart to install on that. So you don't have to go too much in detail in here. Just when I do this command, Terraform apply, let me see, apply, here it is. I did this, and in a few minutes, and I didn't do that live because it takes a while, but in 15 minutes, I had a cluster with 5 nodes in 3 different availability zones with NVMEs, with OnDat installed, and all of this from this template. And by the way, if you want to access it, it's in GitHub, which we took from the official blueprint from Amazon. We took the examples and we built our own. So we have multiple blueprints on that GitHub, on the Terraform EKS blueprints on that add-on. So we install on that as an add-on of the blueprint, which is absolutely fantastic. And I cannot reiterate this enough. When you use this model to build clusters, it just makes it so much easier and so much better to see what's going on, to see what happened, to see, oh, we did this change on the infrastructure a few months ago. We've been having problems. We don't know why. And down the line, you go, actually, I think we've seen this problem for 2 months. You go check the changes and you see that something changed on the infrastructure because it's traceable. And this happens to us all the time. Cool. So,
Hey, Farhan?
Yeah.
Can you share those GitHub links, those GitHub URLs with us?
Yeah.
I will do it right now.
Fantastic.
Okay, cool.
Thank you.
Yeah.
Cool. So one thing that I wanted to discuss is among data services like high availability and high performance encryption that we have read once volumes, we have read many volumes. There are different models and topologies that we can implement. The centralized is the more traditional one, which is we're going to stack data in a few nodes and access everything through the network. So when you have this kind of logic, you can start deciding where you place the data, right? And you can start doing smart decisions. We have the hyperconverged mode, which is the default and the most common used. It's simple, it's simple, but also it gives a lot of scalability. You need more capacity. Scale your node groups, make your scaling group bigger. You need more throughput. Just add more nodes. That's it. You don't have to do anything else. Automatically, it's deployed there. New volumes go there. It's easy. And also, it has a best effort placing data and app together. So we have this Kubernetes scheduler that we tell Kubernetes, hey, the data is in this node. Please put the application as well there. So there is lower latency. We don't have to go to the network. We can, but we don't have to. And this really helps. And this model can also be, and this is what I wanted to come at, can be something mixed. It's dynamic, it's based on labels and nodes, it's super simple to define what's what. And let's say, for instance, you have an autoscaling group. What we see, and this is something we see with a lot of customers that use EKS, and that's where I wanted to get at on today, is we see this a lot. Stateful node pools and stateless node pools. So because by doing this, I'm adding complexity, for sure. I'm saying a few applications go into these nodes, a few applications go into these other nodes. Now, what I'm going to do is, instead of using a centralized model where data runs on a few nodes and is accessed to the network, what I'm going to do is I'm going to keep data on a few nodes and the applications that use that data on those nodes as well. So Elasticsearch, Kafka's, MySQL can go into these 3 first nodes. And their data is going to be there. So we have low latency and it's fast and it's performant. We have replicas. And also, the important bit there is we have scaling policies that are different than the stateless node pool. And scaling policies on stateful workloads need to be a bit more relaxed, need to be a bit more careful. Why? Because when you move data takes a long time to move. Data needs to be there. Data needs to be safe. You don't want to shoot 10 nodes at once because they hold data. Now, maybe you want this with stateless applications, with the web applications, with the machine learning, with compute-based applications that, hey, maybe I need 100 compute nodes now, and at 3 p.m., maybe I need less. I used to, for instance, work on media companies and newspapers and magazines and things like that. And hey, at 8 a.m. in the morning, they had a spike. You put more boxes there. You can scale hard on the stateless applications while you keep the other ones on a different policy. Cool. So yeah, we're going to pass to EFS. Is there any questions until here? Anything that is come up?
I think we hit almost everything in the chat that I saw come up.
Fantastic. Cool. So one of the things I want to
talk... One thing I guess maybe we can expand a bit more on is that somebody mentioned Longhorn, how they've been using Longhorn and how similar are we to Longhorn. Do you want to expand on that?
Sure. So Longhorn is an open source project that is an incubator mode, I believe. I don't want to be wrong now. I don't know if it's incubator exactly. I think it's incubator in the CNCF. And it's a project that was given by Rancher to the CNCF. What Longhorn does is it provides persistent for containers. But it follows a model where it does container as a storage. It's called a CAS model. This means that every time you have a volume, a persistent volume claim, let's say you want also a replica because you need multiple instances of the data to be safe, what you do is you create a pod. And you create a pod for the primary of the volume, and you create a pod, or in this case, Longhorn creates a pod for the replica. That, and then it plugs that pod into the node where the application needs to run. So initially, the architectural concept is very interesting because it's leveraging Kubernetes application allocation to hold data. And actually, is at that time was when that was perceived or designed was quite revolutionary. But what's the issue here? Scalability. What happens when you have 100 PVCs and every PVC has 2 replicas, or actually 1 replica, primary and replica, 2 instances of data? What happens is that you will consume the amount of pods and CPU and memory that you can run on your cluster by just running volumes. And that, from an architectural model that is very interesting, has a systemic design problem. So that does mean that it's not a valid. No, it works really well for the use cases that works well. Let's put it this way. The performance is not the best. I would say the performance is not the biggest point for Longhorn. Let's put it this way. And where do you use Longhorn, and why do you use Longhorn, and where I can recommend it? If you have development clusters and you have a few volumes, like 5 or 6 volumes in the whole cluster, and they don't need high performance, yeah, use Longhorn. It's easy to set up. It's very smooth to install, really. It's just a Helm install, and that's it. You don't have dependencies. You don't have much stuff to do, and then you can start provisioning volumes. But if those volumes need performance, it's not going to work out. If they use databases with low latency, it's not going to work out very well. And in the end, if you need to put a lot of volumes, you're going to end up killing your own machines using pods for infrastructure rather than pods for applications. So I'll summarize a bit on that because I went a bit out of the line. So if you have fairly small clusters or development clusters, something simple, use Longhorn. If you need something with more production-like, more performant, that needs to scale a bit, you need to start looking at other things.
Okay.
That is my personal opinion, to be honest. I mean, I can be wrong and you can have a different opinion. That's completely fine.
Yeah, it's one of the things that I always try to make sure to tell people. People always, they get really, I don't know what you want to say it, like personal, like their preferences or whatever. I always try and get people to realize everything, depending on what you're trying to do, the right tool for the right job. Like you're not going to be using a hammer to screw something into a wall. Like, people, same with programming languages. Oh, this programming language is better. This is better. It just depends on what you're trying to do.
Yeah.
But yeah, I mean, from what we've learned so far, I mean, overall, OnDat's disco blocks, yeah, like if you want that higher performance, that more, obviously that's going to be better. But if you're just like trying to do a quick dev, maybe Longhorn might be the better case for, those other kind of things.
100%. I mean, you can be opinionated on things, and I'm the first one to be opinionated, but I agree with you 100% that, hey, there are things that are, for instance, if you have a team of 2 DevOps or 1 or 2 DevOps, you don't think that you have to manage. You want things, you want low friction, right? You don't want to spend too much time having to learn specifics into things or how to tune these. Maybe you want a simple solution. Oh, but maybe that simple solution is not as performant. Yeah, that's fine. So I agree with you 100% that there are tools, they're the right tool for things, there are preferences. For instance, Longhorn is completely open source. So in this case, 100%. If you have that use case, use it for sure. It's a very interesting project.
Also, you mentioned CNCF. What is that?
That's the Cloud Native Foundation. Pretty much is the evolution of the Linux Foundation, which manages Kubernetes. Is the organization that manage Kubernetes and other software projects. So usually open source, not usually, open source projects. So it's an extension of the Linux Foundation for the cloud native, like for a bit of the modern things. And Kubernetes is the main project for the CNCF, but there are others like etcd. Kubernetes was given by Google to the CNCF. etcd was a CoreOS project, and then Red Hat bought the project. I think is also a CNCF project. In this case, Longhorn is a project given by Rancher as open source to the CNCF. So it's the organization, which is, I think, is a non-profit. I'm not sure, but I believe is. I'm not going to say because I don't know. Is this agnostic organization that tries to promote software and open source, and they take some software, they evaluate, and they graduate according to their maturity, and they have a whole spectrum of software available that is one umbrella underneath all these open source projects.
Thanks for that awesome explanation, man.
Yeah, sorry, I'm just not sure about what I can say or what is exact details. So please don't take me like it's not. Don't take me into. Don't quote me. Let's put it this way. Just trying to give what I think I know. Let's put it this way. Cool. Any other questions? Anything else?
One update from the GitOps poll. It looks like we have a 50-50 split of people using GitOps and people not using GitOps.
Yeah, that's a good one. So if you start from scratch, do yourself a favor and start using the lifecycle. It doesn't have to be complex. It doesn't have to be a full-fledged lifecycle with 25 steps. It just can be, try to make it in a way that if something changes, it has to pass through a source code. It has to pass through something, because then you have history, then you have a way to reproduce, but also you have reviews, you have ways to share information. I've seen with customers so many times the way going one way, it will save you time down the line if you would if you use that approach. Again, doesn't have to use it for everything, but if you want production clusters, at least for production, it's a good thing to do. Cool. So I'm going to move to something that we see very often. We see very often EFS for containers. EFS is a service by Amazon Web Services, which is based on NFS. So it's pretty much an NFS server. And what we've seen is that people using containers is using a lot this service. It's because it's the best tool for the job, not specifically for containers. NFS has been around for decades, and it's really good at a few things, and it's not good at other things. And I think that anyone that has used NFS over the years or has experience with it will have their own battle stories. So why I'm commenting this, where I'm coming to the EFS. EFS is something that is shared file system, meaning multiple instances, multiple applications, multiple containers can write to the same file system. So if I have 10 applications, let's say a Tomcat to run a Java application, a JVM, they can all see the same configuration file. They have, for instance, an XML to the configuration, and they can see the same config file. Now, how is it usually used? Usually is a way to exchange information in between containers, or is used to share things like images or assets that need to be loaded. My recommendation, if you need to load assets from an NFS, put it on S3. Put the assets on S3, put the statics on S3 if you're running web servers, and make the applications retrieve from S3. It's going to work much better. S3 doesn't have bottlenecks. S3 has infinite bandwidth and capacity, and it's just magic. NFS, it's a shared file system, and that means that every time there is something that needs to change on the file system, there is a network call that goes checks if you can do that change on that file. Keeps file descriptor open, and it's EFS has performance implications, right? So what we have seen is customers asking, how can I either improve EFS or do regret many volumes? So accessing one file system from multiple containers at the same time without using EFS. Again, EFS is really good for a few things. For containers, it's not great. Why? Because it's designed for a traditional environment. It's designed for traditional virtual machines and traditional hardware, traditional bare metal, not that much for containers. It has performance implications and it has operational implications, because it is this model that has been running for decades. What it has been done for containers is putting what is called a CSI plugin. CSI plugin is the code that runs in Kubernetes that is capable to talk to this other system or configure this other system. Now, that is putting a bit of a glue, let's put it this way. So one thing that I wanted to show you today as well is, if you have run volumes on EFS, you know what it takes to provision them. You need to provision a volume, an EFS share, configure some IAM roles. Then you would have to go to your Kubernetes and create the object that maps with an ID to the EFS. It's a long story to say, I want a volume with this share file system. So what do we do? It's basics. We just provide regret many capabilities. And what we do is we keep the NFS shares inside the Kubernetes cluster in a completely transparent way. So OnDat has the regret many capability, and the only thing that you need to do on a persistent volume claim is add this flag. Nothing else. So if I do this, you have a regret many volume available. It's a kubectl create, the persistent volume claim, with a regret many access mode on storage as storage class. And the way we do that is we create the volume internally, and we have a way to present NFS internally, and we have high availability for it, and it moves between nodes when we have to. And we have one NFS server for every volume that is regret many. So in this case, I just provision the regret many volume, and that's it. I can start using it. There is nothing else I have to do. I can create a deployment. So I can create, for instance, 10 instances of an Nginx and mount this same volume. And they will be able to see each other's files. Why I'm saying this is because we've seen with a lot of customers that they struggle. So they ask us, and we've been working with some Amazon teams as well. And they said, okay, we need hard numbers. So a customer asked us, let's do a use case together where we can do a proof of concept and see what we're going to do. So what we did is we run on a 3 instances the 2x large from the i3 class of EC2, which is pretty much the one that has the NVMEs. And we put 5 terabytes of capacity. And we created an EFS, standard EFS with 400 megabytes as pre-provisioned throughput with no lifecycle policies. Pretty much policies mean that you can say, after a while, make this data go to a storage layer that is slower, for instance. So we end up having the numbers of being almost 60% cheaper and way faster. So again, this doesn't mean that EFS doesn't work well. No. EFS is a fantastic solution for what it's intended for. It's not intended for containers. So people keep using it because it's easy to use there, but we have an alternative for it. You don't have to use that. You can keep using EFS, but at least you know that there is an alternative. So on top of that, now I said, oh, EFS doesn't work well for containers. What about EBS and all that stuff? So EBS is the block storage from Amazon Web Services. And I believe, in my opinion, is probably one of the most stable and best services that Amazon has ever created. That's a very personal opinion again, but it works really well. It just works, right? But there are a few things that it cannot do. And one of the things that our customers have come to say, hey, can I use OnDat to improve what EBS can do? So instead of using NVMEs, we use EBS all the time underneath OnDat. So the workers of Kubernetes use EBS, and we run on top of that. So I was discussing with Angelos that the other day on a use case with a customer, and I think it's better if he explains, because that's a first-hand use case that we saw the other day.
Yeah, one common pattern that we see is customers that create one instance of their stateful application. For example, a common thing is a Prometheus instance, where you have one pod and then one EBS instance, one EBS PVC that is connected to that pod. So then we know that EBS can only be attached on EC2 instances that are in the same availability zone. So what happens when the availability zone goes down? Well, you have to just wait for it to come back up. The difference is with OnDat, if your availability zone goes down, in milliseconds, the failover process is going to start, and you'll be able to get your application back and running in seconds or minutes, compared to an availability zone outage, which would take hours in the case of using an EBS volume.
Mm-hmm. Yeah, so it's unlikely to happen, right? Sorry to interrupt. I didn't hear you out there.
Oh no, I was just gonna go back a little bit to the talking about how EFS isn't the best solution for containers. My previous position, my senior DevOps engineer, we used, I don't even know how he did it, but he had to jury rigged some weird, like I think the container was specifically called like fake EFS, and he utilized fake EFS and EBS at the same time in order to simulate like a shared file system, and it worked, but it was super like, I don't even know. It was so clunky and weird. Like I couldn't even try it again if I wanted to.
It has some gotchas that you only see after a while, and yeah, that doesn't mean that for instance with EBS it works well. It's a bit expensive, let's say that, but it works well. You have availability, constantly availability, and it works most of the time. But it's designed for virtual machines, and that means that a virtual machine life cycle, what we usually see is, hey, you have a life cycle of a virtual machine that is starting, living for a while, and being deleted, and that can take minutes. Usually you get charged by an hour, so that's a good indication of the life cycle of a VM. It can run for years. Now a container is a bit more ephemeral. A container spins up in seconds, and you can move containers all the time, and because they spin up that fast anywhere, you just start and stop them fast. That means that EBS struggles a bit with that attachment time, having to move containers in between nodes. It's not really, it's a use case that you can move an EBS, detach it from one node and attach it to another. It's a capability, but it's not intended to do that all the time. With containers, you can be doing that all the time, and EBS starts suffering. So what we come to provide is the capacity to give EBS what's good at, and let EBS do backend storage or the OnDat backend storage. And we can do the container-centric storage. Hundreds of provision volumes, attachment, and failovers. Hopefully you don't have hundreds of failovers every day, because then your cluster is a bit broken. But it's to say that you can provision volumes, and you show how I moved a master before in the demo, a primary volume in between one node to another in milliseconds, no hiccups, no nothing. So we can let the system is designed for containers do the containers, the system that is designed for VMs do what it's good at, which is VMs. And on top of that, there is what Angelos mentioned about the topology word placement, which is because we control where we put data, we can start doing smart things. We can start saying there is a label on the Kubernetes clusters, which looks like this. Let me find it. It is topology.kubernetes.io/zone, live zone, that will list the nodes, according to the failure domain that they have. So in this case, we can say, put the primary, if the primary lands on this failure domain, we'll guarantee that the replica lands on a different one. So we are improving EBS here as well to give more capacity or give more safety. And on top of that, we can do eye optimization. So let's say you have an EBS, and that EBS by default, for instance, the GP3 has 3,000 IOPS of available input-output operations per second. Now, if I have one MySQL using that volume, that MySQL might be using now 100, then 1,000, then 3,000, then 300, and over time, it underutilizes what's available. So what did we do with compute resources? We created virtual machines in the industry because we had servers that were underutilized because they had a database that used 10% of the CPU, then 80%, then 1%, then 100%, then 0 for a long time. So what did we do? We create virtual machines to allocate CPU much better. And containers is the alter ego of that. So we can do the same stacking I/O. We can go and say, we handle, let's say, 20 volumes in one node. We're going to grind to the same EBS because OnDat handles all the input-output operations and it's very efficient. But in the end, we're having multiple applications and stacking the performance to maximize the utilization available. So finally, and just to come here, RDS as a managed services for databases. Now, with what we presented, you can think, oh, maybe I can run databases in Kubernetes. Yes, you can. Again, use what's best for you, meaning if you need a managed service, use RDS. If you have one person operation team, use RDS. If you want to manage it and have more flexibility and have the high availability that we've mentioning it, you can start using more cost-effective options. However, don't start optimizing when you don't have to. So optimize when you have a problem. So to conclude and to pass a bit to explain what Disco Blocks is and what's coming, I just wanted to recap a bit for the people that maybe came late, which is you can use the EKS blueprint for production with reproducible infrastructure using GitOps, which is an absolute great way to do things. If you're not doing this, do yourself a favor and just look around a bit. Running stateful workloads in EKS with OnDat can have benefits and will have benefits whether you use EBS or NVMEs. You have options and you have more options to keep your data safe, whether it's with EBS or NVMe. We can run regram many volumes as well that are actually pretty easy to run, and you can run databases on Kubernetes. You can run stateful applications on Kubernetes. Cool. Any questions? We're going to pass to Disco Blogs, but if there is any questions, I'm happy to cover it now.
I don't see any in the chat at the moment.
Probably people is half asleep because I killed them.
No, you're good. You're good, Doug. We had some of those questions we talked about maybe earlier. So here's one. Does OnDat work on EKS Anywhere or other bare metal clusters?
Mm-hmm. That's a really good point. So OnDat is completely agnostic as soon as you have a fairly standard Linux distribution. I use an Ubuntu today, but you can use Red Hats, you can use whatever. We're agnostic in the sense that as soon as you give us capacity, we will use that. And as soon as you have a Kubernetes cluster, we will use that. It can be EKS, it can be EKS Anywhere on bare metal. We also run on VMwares. We run on different platforms altogether. So anywhere you can run a Kubernetes cluster with fairly standard Linux distribution, we can run there.
Nice.
So, is there any limits to how many volumes we can make per node?
So the amount of volumes per node is not about how many we can have. There is a limit, but it's a software limit on a const that someone said. So there is no effective limit. The limit is in the usage. So to be able to do input-output operations, we need resources. We need a bit of memory. We need CPU. We need network. We need threads to send the replication input-output operation. So it depends on how much traffic the volumes have.
Okay.
So usually, actually, in the market, we are one of the most lightweight storage providers that there are. I'm proud to say that. But even that, we need resources. I would put a 10% of the machine for on that. If you have, I don't know, 20 volumes, yeah, it's gonna be fine. If you put 150 volumes and they're on fire and you have 4 CPUs, yeah, it's not gonna work out very well.
Yeah. We have one more question in the chat. Does it support KubeVirt and VMs on bare metal with EKS-A?
Yes, 100%. So
Okay.
we have a use case with people that have built a whole data center from scratch using KubeVirt. We are the backend of KubeVirt. So every root file system in KubeVirt in that data center is an OnDat volume.
Nice.
There's a bit of magic to do there. It's not trivial, but to run KubeVirt because there are different layers of abstraction. But yeah, there's no problem at all.
Nice, cool. Yeah, do you want to dive into disco blocks?
Sure.
Yep. Let me talk to you a little bit about Disco Blocks. As an introduction, Disco Blocks is a new open source project that we have developed at OnDat. Before I discuss exactly what it does, I can explain to you the problem that it solves. As a lot of people that do use EC2 instances will probably figure out quite soon, is that it's quite easy to manage your backend disks when on startup of an EC2 instance, but when the instance is running, this starts to become a bit more difficult. For example, if you want to resize an EBS volume, and what you would do is that you would resize it on the actual console or whatever infrastructure as code you're using, and then you'd have to do a grow part on the machine itself to be able to fill up the partition. A lot of work, which might be fine for one instance, but when you have hundreds of them, you need a way to automate this. And that's what we thought at OnDat. And because, as you probably noticed, a lot of focus on the way we work is based on the backend disks. So we want those backend disks to be easily able to be managed, expanded, provisioned, etc. So that's why we had this motivation to create a tool that automatically manages those backend disks on the cloud. Another motivation we had is that we actually wanted to give back to the open source community. A lot of the stuff we're using in-house is open source. Kubernetes is open source. OnDat is not fully open source. A big part of it is, some part isn't. So we want to give back to the open source community because it is helping us as well. So we want to make this project something that is not just useful for OnDat, but it's useful for everybody that wants to use it, which also includes our competitors, actually. So what exactly does Disco Blocks do? The two main features that it has is that it provides automatic provisioning of backend disks in a very, very simple manner, which I will explain to you in the next slide. And it also allows for automatic resizing of those backend disks based on thresholds. So if you're using 70% of your backend disk, Disco Blocks is going to realize that this is the case and will automatically resize and fix your partition without you even having to worry about it. And all of this that I'm describing now is configurable. So how does Disco Block work? Well, we're utilizing the Cloud CSI or Container Storage Interface driver. In this case, for this example that I'm describing, it's the EBS CSI driver. But of course, this is cloud agnostic, but most of our demos are being done on AWS. This is very useful that's using the container storage interface because it's very easy to provision volumes and resize volumes this way, and also, of course, delete volumes because it's using an interface that actually OnDat also uses. This means that these backend volumes are actually going to be exposed as PVCs, similar way as OnDat. The other thing that it utilizes is a sidecar container injection. So when you have a pod, then Disco block is going to inject a sidecar container that's going to be provisioning the disk and checking the utilization of that disk and doing actions based on what the utilization is. And also Disco blocks is using a CRD operator model. So again, similar to how OnDat is working, you have an operator, a custom resource definition, and that's what CRD stands for. Then you create a CR file, which contains a different configuration of your backend disk. And Disco block is going to create your disk based on different configuration that you have applied to it. So Fran, if you go to the next page, I can show an example of a disk config. This is the custom resource I was talking about, and it's very simple to use. So as long as you have installed Disco blocks on your machine by following the documentation, the only thing you need to do to make this work, assuming you also have the EBS storage class, which this is one of the requirements to use here, you set up this config, which has just some metadata, which is the name and the namespace that needs to be applied on, and then a storage class name, which in this case is EBS SC, which stands for storage class. For those who don't know what the storage class is, it's basically a template of PVC creations. And usually this is backed up by a CSI driver. In this case, this is the CSI driver of EBS. Then you can select what capacity your backend disk, the backend disk you want to have. It's, in this case, going to be 1 gigabyte. And then a mount point pattern. This mount point pattern is going to be the specific location of the host file system where this storage is going to get provisioned and mounted on. Then you have a lot of other configurations, which I don't want to go too much about. Things like node selectors, which is a Kubernetes concept. It basically selects that you can only use this on a Linux machine. If there's a Windows node, of course, this is going to fail. And then we also have the pod selector, which is a label that the Disco blocks is looking at to check which pod it should provision on. These are very standard Kubernetes terminologies. So of course, these concepts go also translate into other Kubernetes concepts. So if you want to learn more about them, you can also look at the Kubernetes documentation. And finally, and most importantly, there is the policy stanza, which is the upscale trigger percentage, basically the percentage of usage that Disco blocks is looking at. And when that percentage is reached, then Disco blocks is going to automatically resize the disk capacity of your backend disk. Now, in this case, it's only 2 gigs, but in a probably more real scenario, you might have an 100 gig EBS volume. And then when you're reaching 70%, 50% capacity, this is going to increase it into 200 gig volume. It's quite simple it's quite a simple config, but it can have a lot of powerful applications. For example, on the use case of OnDat that Ferran was also mentioning, is that you can, for the example of NVMEs, in the specific scenario that Ferran was talking about, it's very difficult to expand NVMEs because they're part of the node and there's no easy way. It's not network storage. It's in a physical disk.
You can have a guy going and unplugging disks, right, to a machine. It's going to be a bit difficult to do that.
Now we know James and Shardul, so maybe we can ask them to go and change it for us in the data center. But in general sense, you can't really expand an NVMe. So that's where Disco blocks come in, and with a disk config and having the pod selector be app storage OS, then you'll be able to add extra backend disks onto your already provisioned OnDat cluster, which will allow you that if you want to expand the storage capacities of your NVMe cluster, you can very easily use Disco blocks and add an extra EBS volume, which will allow you to have more capacity and infinitely expand with just adding more disk configs, and automatically, without you having to worry about it, it will create more depending on the disk utilization that you're having. So yeah, that's a brief summary of Disco blocks. If you want to try it out, if you want to contribute, even better, you can find us on GitHub on the / Disco blocks. It's still a new project, so it's still ongoing. Maybe some things documentation probably might need a bit of work. So if you want to raise any issues on the GitHub repository, feel free, and we'd love to hear your feedback. And yeah, that's it from Disco blocks.
And that's open source, right? So people could contribute too, right? If they want to.
Yeah, exactly. It's not OnDat specific. It's very helpful for OnDat, but this works for any kind of any CSI volumes. You could actually even use it for OnDat volumes too, if you want to be expanding them.
Nice.
Yeah, it's we have an initiative for open source, and this is the second project, or one of the main projects that came out, which is very new still, but it's getting traction. And also we have one that's called Trousseau, if someone wants to have a look. So we have multiple open source projects that our engineers are contributing actively.
Fran, do you want to talk about our portal?
Sure. So I showed before this. We haven't talked about licensing and things like that. We just we announced a fairly new price model out of late, like last week, which pretty much reduces the price. More than reduces the price, it gives a very competitive price on full functionality. So if you want to use OnDat, is the community edition is available, is free, and has full functionality. So if you want to use it even in production, you can use the community edition. If you want something more as a pay-as-you-go and things like that, it's I think it comes like $8 a month or something like that per node. So it's also quite cheap, with support and things like that. But yeah, I don't want to go too much into detail with pricing. It's just that we release a new pricing model, which is super competitive, and the community edition is free and it's available and it's full functionality. So today, actually, everything I did was on a community edition license.
Nice. Is this also on the AWS marketplace? Do you know? Could they utilize it just straight through the marketplace?
I believe it is, yes.
Oh, exceptions.
I believe it is. I'm not the person that was in charge of this, so I would need to ask to confirm, but I believe it is.
Okay. Yeah,
It
that's
is, yeah.
definitely something we need to take a look at, because it makes it even easier to get it, into your solution just right away, just a click of a button. So, is there anything else you guys wanted to plug?
I think we covered a lot, but if there's any questions or anything you guys want to know, we're happy to cover. Otherwise, you can also contact us. We have public Slack channels that you can contact us, on the website as well. We have a few chats that are available. So yeah, feel free to contact us if you need anything.
Nice. Oh yeah, we just got the link for it's on the marketplace. Awesome. So yeah, you can just check it out. All you developers out there, just fire it in. Yeah, and then so I know someone mentioned earlier. I just wanted to back up and we were digging deep today, for sure. One of the questions earlier was, Fran seems like the EKS, forget the word he used, guru, master, something like that.
I think
And
champion.
champion,
Yeah.
yeah.
Been using
He
it for a while, that's all.
Yeah, he wanted to know. His question was, do you believe like EKS is the future? Like, I kind of answered it in the chat, but what are your thoughts on that, on Kubernetes and EKS being like the way to go?
So that's a difficult one, but one thing that we used to see is that people going for big clusters, and over time what we have seen the evolution the last year and a half is that people is going for more clusters that are smaller.
I see.
Where I'm coming from this, people And I used to work a lot with OpenShift as well. OpenShift is a distribution from Red Hat, and Amazon, for instance, has also the managed service called Rosa for it, which you want to run containers with the Red Hat flavor of Kubernetes on steroids. You can do that. But more and more, we see people wanting less management and more workers, more smaller clusters that can do specific things. And because there is more automation alongside creation and deletion of clusters, EKS is a good example of having a lot of small clusters and a very easy way to manage. You want to have disaster recovery in between clusters, it's easier. You want to have an active passive cluster, you can do that. The upgrades on EKS are super easy because you just click a button, it's rolling. So in the end, you don't have to manage etcd. Managing the control plane of Kubernetes is a bit unnecessary, to be honest.
Mm-hmm.
So I believe the managed services are the future. Yes. I believe they are going to be the only ones. Probably not. We see a lot of bare metal, and we see a lot of people in bare metal and going away from bare metal VMs containers to bare metal containers straight. So this, what I think it taps a lot to, is the EKS anywhere.
Yeah, that makes
For
sense.
a lot of corporate customers, or more than corporate, like customers that have both their own data centers and cloud accounts, this starts making a lot of sense because you have EKS out there, you have EKS at home in your own machines, and this gives these hybrid clusters that people, or these hybrid topologies that people keep wanting to use. Long story short, I don't know.
Yeah. No, there's definitely it's one of those things where it's definitely the it's a very powerful tool. Might not be the best tool all the time, but it's turning out to be definitely one of the most powerful and popular tools. Um, there's actually, I'm gonna type it right here. There's actually it was a not a demonstration. It was a talk at reInvent about. It was just another question about how popular and what industries containers and EKS and ECS are being run in. Apparently, what was it? About 2/3, I believe, of all industries are running. Let me see
Two
if I can
two
find the
thirds of the
number.
containers that run in the cloud
Yeah,
run
are
on
running
AWS. Yeah.
running on AWS. Disney Plus is, I'm sure a lot of people who subscribe to Disney Plus is running containers on ECS. It just goes to show how powerful it can be if you leverage it correctly, and it's just goes to show like just how powerful the cloud is in general. I still can't get over it sometimes. Uh I mean, not to get all cheesy on everybody, but anyway, I guess if that's it, if and no one else in the chat has anything to say, if you guys have any last words, I don't know. We can call it here and thank everyone for coming out.
Yeah, thank you all for coming and for listening for so long.
No, dude, I could listen to you. Like I said, I love your accents. I love tech talk. We could I could do it all day. So for sure. So all right, thank you everyone for coming. Thank you, Fran and Angelos from OnDat, and from everyone at Howdy Partner. Tune in. We're here Wednesdays 2 to 4. Maybe not next week. Trying to get something going, but we're trying to get a show every week. Um, thank you all for coming. Happy trails. Giddy up, y'all.
Bye bye.
Bye.